What hides at the very heart of a galaxy? For a long time, we pictured a single, hungry monster, a supermassive black hole, sitting alone like a king on a dark throne. But the truth might be a little more crowded, and a lot more interesting. A small cluster of bright, hot stars called IRS-13 sits almost on top of the Milky Way's king, Sagittarius A star. You'd think the giant gravity of Sagittarius A star would tear any nearby group apart. Close to a supermassive black hole, stars should be scattered, not marching in neat rows. Yet these stars move together in a tidy dance. That was the puzzle. After careful watching with very sharp telescopes, astronomers found a surprising answer. Hidden inside that tidy dance is a smaller, shy black hole. An intermediate mass black hole. Not tiny, like the ones born when single stars die. Not huge, like the beasts that live in galaxy centers. It's the missing link, the middle child that fills a gap in the family. This smaller black hole seems to hold the star cluster together while also flirting with Sagittarius A star, tugging and trading orbits in a slow, cosmic duet. Black holes grow by eating. They swallow gas, dust, stars, even smaller black holes. Over billions of years, a little black hole can bulk up. Somewhere along that path, a black hole might pass through an intermediate stage. Seeing one of those middle stages is rare. That's why IRS-13 is exciting. It may be a real-life snapshot of how black holes stack up to become the giants we see at the centers of many galaxies. And we're not just talking about our Milky Way. Look at galaxies across the sky, from the broad sweep of Andromeda next door to far-off smudges in deep space photos. Many show bright, compact hearts. Some are quiet. Some blaze with light as matter spirals in. Maybe, behind that light, there's not just one ruler, but a whole court. Small black holes, medium ones, all gathering, merging, growing into the huge engines that shape their galaxies. Imagine a city at night. You expect one main tower lit up at the center. Now picture dozens of smaller buildings close by, each with its own light and pull. The city's shape changes because of them. That's what astronomers are starting to suspect about galaxy centers. The discovery in IRS-13 hints that the story of galaxy growth is more of a family saga than a solo biography. This changes how we think about where supermassive black holes come from. If intermediate black holes are common, they could be the stepping stones, the building blocks, that let monsters like Sagittarius A star arise. The stars orbiting IRS-13 are the clues. Their neat motion is a map to the hidden mass at the center, a mass we couldn't see, but which we can feel through the star's dance. Think of black holes like people. They're born, they grow, and they change. We know the baby black holes, made when giant stars die, and we know the elders, the supermassive bosses at the centers of galaxies. But the middle ones, the intermediate mass black holes, are the missing chapter. They're the awkward teens of the cosmos, and finding them could rewrite the story of how the biggest black holes formed. Why are they so hard to spot? First, they can be quiet. A supermassive black hole eats huge amounts of gas and lights up a galaxy's center. A stellar black hole can shine if it steals matter from a close star, but an intermediate black hole might sit where there's not much to eat. No light means no obvious sign. Second, they hide in crowded places. If one sits in a tight star cluster, its pull can look like the pull of many stars together. Untangling that hidden mass from the motion of stars is like finding one strong dancer in a packed floor. You need very fine tools and patient watching. Third, the right places are rare. The conditions that make mid-sized black holes might happen only in certain star nurseries or during galaxy crashes. That makes good targets few and far between. How do scientists try to catch them? One way is to watch stars. If a group of stars moves as if something heavy sits in their middle, that's a clue. Another way is to listen for ripples in space-time. When two black holes collide, they send out gravitational waves. The size of the wave tells us how big the black holes were. Future detectors may hear collisions that involve intermediate mass black holes. Astronomers also search for sudden bursts of light. If a star wanders too close, it can be torn apart and the black hole will briefly shine. Those flares act like beacons. High-tech telescopes looking in X-rays and infrared add to the hunt. Why should we care? Because intermediate black holes could be the building blocks of giants. If many mid-sized holes merged long ago, their unions could have stitched together the supermassive black holes we see today. They could also shape their surroundings, steering stars, nudging gas, and guiding the growth of galaxies. The hunt matters not just for a new find, but for what the find will teach us. It would fill a gap in our timeline of growth. It would test our ideas about how stars, clusters, and galaxies evolve. It might even reveal new physics about gravity in extreme places. A team of astronomers pointed 3 very different eyes at IRS-13. The Very Large Telescope gave sharp pictures in infrared light. ALMA, the radio telescope array high in the Chilean desert, sensed cold gas and dust. Chandra, the X-ray telescope in space, looked for a high-energy glow. Each telescope told a different part of the story. Then, the astronomers fed all those parts into a math model that could turn motion and light into mass and shape. What did the motion show? The stars in IRS-13 were dancing in a tight pattern, as if something unseen sat at the center, pulling the strings. But when the center was inspected directly, it looked empty to the simple eye. Then Chandra found the clue, a ring of ionized gas glowing in X-rays. That glow is a telltale sign of hot gas swirled and torn apart by strong gravity, an accretion disk. Gas falling toward a black hole heats up and emits X-rays. Seeing that ring was like seeing smoke and knowing a fire was nearby. Mathematics turned the motion into weight. By tracing the stars' orbits, how fast they moved and how tightly they swung, the team could work out how much mass must sit hidden in the center to make those moves possible. The number that fit the data was huge. About 30,000 suns packed into a space only a few light days across. That's too heavy to be a cluster of normal stars, and too light to be a supermassive black hole. It sits right where scientists predicted an intermediate mass black hole would sit. That makes IRS-13 a rare and powerful clue. If true, it shows how a mid-sized black hole can hide in plain sight, steering stars and stirring gas while living in the shadow of an even bigger neighbor, Sagittarius A star. It also opens a window into how black holes grow. Maybe giants like SGR-A were built by swallowing many mid-sized ones over time. Or maybe these middle children form in star clusters and then fall inward to feed the central monster. IRS-13 gives us a real place to test those ideas. But the story's not finished. The astronomers want clearer pictures and deeper truth. That's why they hope to use the James Webb Space Telescope and the future Extremely Large Telescope. Webb will peer in infrared with crisp detail and great depth, able to see stars and hot dust through the dense fog at our galaxy's center. The Extremely Large Telescope, with its huge mirror, will give even finer views and faster measurements of stellar motion. Together, these tools can map orbits more precisely, measure the speed and temperature of the gas in the accretion ring, and watch how the black hole, if it is one, tugs at its surroundings. Those next steps matter. Better data could pin down the black hole's true mass, check whether gas is falling in now, and tell whether IRS-13 is slowly spiraling towards Sagittarius A star or happily circling at a distance. They could also reveal if many small black holes hide near galaxy centers, quietly shaping the lives of stars. In plain words, the discovery in IRS-13 is a spark. It lights a new path to learn how the universe builds its biggest beasts. Each new telescope is another lamp on that path. With sharper eyes and patient math, astronomers hope to follow that light all the way back to how the first giant black holes grew, one strange, hungry step at a time.